Now that you've seen a brief introduction to what a logarithm is, in one definition of it, we're going to practice evaluating logarithms without using a calculator. My recommendation is to learn how to say the question. So when they say y equals or f of x equals log base 3 of 27, what it really means is 3 to what power would make 27? 3 to what power would make 27? So you're more familiar with looking at exponents. 3 to some power needs to make 27. And mental math, if you plug in 1, 3 to the first is 3, 2, 3 squared is 9, 3 to the third is 27. So the answer to the logarithmic question, log base 3 of 27, is the exponent. Second example, log base 5 of 5 is equal to what? Log base 5 of 5. Really, that's the same question as 5 to what power would make the number 5. And when I write it in that manner, most people can just test numbers till they find it. 5 to the 0 power is 1, 5 to the first power is 5, and the answer is the exponent. Another example, log of 1,000. Refreshing your memory, if they do not put a base there, then we understand that it's log base 10, the common log. So this really means 10 to what power would make 1,000? Sorry about that. Log base 10 of 1,000. 10 to what power would make 1,000? You could do trial and error. And it's okay to use a calculator if you have to, but most of us 10 to the first is 10, 10 to the second would be 100, and 10 to the third is indeed 1,000. Answer here would be 3. The next one, log base 5 of 1 is somewhat unique. So you have to remember your rules of exponents a little bit for this one. But what it really means is 5 to what power would make 1? And there is actually an answer to that. 5 to the 0 power, any number to the 0 power is 1. They do get tougher. So we're going to look at sometimes the answer to a logarithm expression can be negative or 0. To understand the next section, we need to review a few things about exponents. So I want to refresh your memory, and I wrote out 3 scales here, 3 charts. If you have 3 raised up to the first, we're familiar with that being 3. 3 squared is the same as 3 times 3, or 9. 3 cubed, 27. If I wanted to figure out what 3 to the 0 power is, or where we're really going, what is 3 to the negative 1? What is 3 to the negative 2? Or 3 to the negative third power? What I want you to observe is the pattern on the left. As we go this direction, goes power of 3, power of 2, power of 1, power of 0, negative 1, negative 2, negative 3. There is also a pattern being established on the right side. To get from the bottom number to this number, we divide by 3 or remove a factor of 3. If I go to 9 and divide by 3, that checks again. 3 divided by 3. I'm sorry, 9 divided by 3 is 3. To fill in this box, what is 3 to the 0 power? You do this number previous to it, divide by 3. 3 divided by 3 is 1, as you've heard me say a couple times in the video. A number to the 0 power is 1. It becomes a little more interesting in these next couple. If I try to do 1 divided by 3, and I'm going to write it in fraction form, we get 1/3, or 1 over 3 to the first power. That's going to become important in the next level. If you do 1/3 divided by 3, you get 1/9 or 1 over 3 squared. One more time, if I do 1/9 divided by 3, I get 1 over 27, which could also be written as 1 over 3 to the third power. So what I want you to observe is 3 to the negative 3 is the same as 1 over 3 to the third power. Or if it's 3 to the third on the bottom, you could make it 3 to the negative third. 3 to the negative third is the same as 1 over 3 cubed. And it happens in all of the lists, no matter what number I use. 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 would make 1. Again, that concept, 2 to the 0 power is 1. And then I could do 2 to the negative 1, put the 1 on top, drop the 2 down low to the first power. 2 to the negative 2 would be the same as 1 over 2 squared, or 1/4. 2 to the negative 3 would be the same as 1 over 2 to the third power, or 1/8. And 2 to the negative fourth would be the same as 1 over 2 to the fourth power, or 1/16. And it happens again and again and again, no matter what numbers we choose to use. That's the same as 1 over 5, 5 to the negative 2, 1 over 5 squared, or 1/25. Pause the video and write down the notes that you think would be helpful for you moving forward. Now, the reason that I went over that, if you have logarithm base 3 is equal to 1, then your job is to figure out 3 to some power has to equal 1. It was actually in the chart on the prior slide. Anything to the 0 power equals 1, so the answer is 0. Now it gets interesting. We need to find 3 to some power that will create 1/9. So it might be helpful to rewrite this as 1 over 3. Instead of 9, let's write 3 squared. So that's helpful, but you know the answer is not 3 squared. 3 squared is 9, not 1/9. So if you wanted to, you could do one more step and rewrite this as 3 to the negative 2, which makes it more apparent that we are going to need a negative number if we have a fraction for this thing called the argument. If your argument is a fraction, you want to think probably it's going to be a negative number, fraction between 0 and 1. Okay, we're going to practice that. The answer to this one is negative 2. Practicing that a little more. If I have log base 2 is equal to, or I'm sorry, log base 2 of 1/8, log base 2 of 1/8, that wants me to find 2 to this mystery number needs to be 1/8. If you wanted to try to rewrite 1/8, you could figure out 8 is the same as 2 cubed. That's helpful. But you know we're not going to put a 3 in the box. 2 to the third is actually 8. We want 1/8. You can do that one extra step here and rewrite this as 2 to the negative third. And then that reveals what the answer should be in our box. 2 to the negative third is 1/8. One more time. If you have an argument that is between 0 and 1, your answer is going to be a negative number. Okay. After that, we get pretty special circumstances here. And you have to know your exponent rules, which I'll try and repeat for you as we go. Here, there is no base number. There is no base number. So once again, no base number means 10. Let's think about what the answer might be. We're trying to figure out 10 to some power is equal to the fourth root of 10. It would be really nice if we didn't have radical form. Instead, let's write this using the stuff we learned prior. Instead of fourth root, that's the same as 1/4 power. Voila. There's our answer. Both of these things have base 10, so both of these things must have a power of 1/4 if they are equal to each other. So the answer to log base 10 of the fourth root of 10 is 1/4. Try again. Log base 8 of the fourth root of 8 really wants me to figure out 8 to some power would make the fourth root of 8. I think rewriting this as 8 raised up to the 1/4 power makes it more obvious. If these two have the same base and we want to put an equal sign between them, then those powers must match. That one is also 1/4. You could go over to a calculator and do some checking. Get rid of that one. By doing 8 raised up to the 1/4 power, you can use a fraction, 1 divided by 4, or you can do 0.25. And you could do the fourth root of 8 if you know where to find your special keys. The fifth one down, I can do the fourth root of 8 and see that those two values are equal to each other. Okay, let's try another example. This is log base 2. Again, they put fourth root of 8. But log base 2, 2 to some power that makes the fourth root of 8. Okay, this one becomes extra special. Yeah, we could write it as 8 to the 1/4, but these bases don't match 2 and 8 for the bases, so we cannot say that 1/4 is our answer. However, 8 can be rewritten as 2 to the third power to the 1/4 power. 8 can be rewritten as 2 to the third to the 1/4. Why is that helpful? If you remember your rules from the previous unit, we multiply 3 times 1/4, and we now know same base, same exponents. The answer to this one is 3/4. Okay, we haven't practiced one like this. Remember, if it's ln, not log, that you can rewrite that as log base e of the cube root of e. Our goal, e to what power would make this? Let me write it in a different color here. E to what power would make third root of e? If you rewrite this in exponent form, e to the 1/3, it's more obvious. The bases match, so the exponents must match. The answer to this one is 1/3. Answer 1/3. Log base 4, fourth root of 64. 4 to what power would make fourth root of 64? Let's change it to 64 raised to the 1/4 power. Still doesn't work because we don't have 4 for the base, but lucky for me, 4 to the third power is the same as 64. So 64 raised to the 1/4. So 4, multiply those powers. Now we can say that they have the same base, so the power must be the same. In other words, 4 to the 3/4 power makes this, and our answer, be careful not to write 4 to the 3/4. The answer is 3/4. ln means that there's supposed to be a tiny little e, or it could be written as, in a different way, log base e, and then the 5th root of e to the 4th power. Means, can we figure out e to what power makes this argument? Our answer. Rewrite it instead of radical form. Remember the index number is the denominator, and the power goes up here. And now we have same base, so we have to say, conclude that the power would have to be 4/5 to put an equal sign between them. Answer to the question is the exponent. The answer to a logarithm is an exponent. I have some more special examples because I think these take a lot of practice. This one is wanting me to find 6 to some power that is the 4th root of 216. I can use my rules. Radical is the same as thinking of that as 1/4 power. I would want to try and change this to match this base. So on our calculator, we know 6 squared is 36. So let's go 6 raised up to the 3rd. Yep, 6 to the 3rd is 216. So this then practices your rules from the last unit. Multiply power to a power rule, 3 times 1/4. Now that I made these bases match, that means the powers or exponents have to match. The answer to a logarithm is the exponent. 4, next problem here, 4 raised up to what power would make 1/32? Now, I have already gone over that if it's a fraction between 1 and 0 in the argument space, we're going to be thinking of putting a negative number here. However, when I did it last, this was easy to figure out. It was 4 to some power. 32 is not 4 to some power. So now I need to be really creative. Since I'm unable to write this number, 32, as 4 to some power, I'm going to try something different. Let's change this one and call this 2 squared to some power. Why would I want to do that? Because 32 is 2 raised up to the 5th power. And you can always test it out, 2 to the 4th, 2 to the 5th, till you find it. So now I can write 32 as 2 to the 5th power. 1/2 to the 5th power is the same as this. Now I can do 2 to the negative 5th. Here, I'm going to put a little x right here because I'm trying to figure out what that is. 2 for the base, 2 for the base. If I'm going to figure this one out, 2x has to equal -5. 2x is going to have to equal -5. So now that I know 2x has to equal -5, I can conclude the x value I need to put in the box is -5/2. So the answer to the overall question is -5/2. I can show you on the calculator that it works. Oh, wait, can I? Yes, I believe I can prove that it works. Got to get creative here. So I'm going to do 4 raised up to the negative 5 halves power. Fraction up there, negative 5 halves, whoops, go down, 5 halves power. And then I'm going to do 1 divided by 32. If I've done it right, we should match in those numbers. So 4 to the negative 5th is indeed the same number as 1/32. And then again, the answer to your logarithm is the fraction. On this one, let's see. Notice that these two look almost alike, but the argument and the base are switched. And we have to use that same trick that I showed you in the last one. 16 to some power has to equal 64. So I can't do 16 to a power that makes 64. It's not a 1, it's not a 2, it's not a negative 1, it's not a negative 2, because that would give me a fraction here. So it's going to be some kind of decimal. I need to think of a number that I can do some number to a power that makes 64 and that same number to a power that makes 16. I said that backwards, sorry. Now, both 4 and 2 are acceptable to work with. You can write this as 4 squared to our mystery number equals, and then you can write this one as 4 raised up to the 3rd power. You could use 2 because you can do 2 to the 4th box and 2 to the, what number would that be? 2 raised up to the 6th would make 64. So either one is going to get you the right answer. Our goal, fill in the box. So let's write this one as 4 raised up to the 2x, and this one as 4 raised up to the 3. If there's an equal sign and they have the same base, then these exponents have to be equal to each other. So little equation, divide by 2 tells me my correct answer is 3 halves. If I took the time to check, you could do 16 to the 3 halves should equal 64. Let's go ahead and finish our last 2 to 3 examples here. If they switch the argument and the base, now we need to do 64 raised up to some power needs to be 16. Again, 64 can be written as 4 raised up to the 3rd power, and we still have raised up to a power. And 16 could be written as 4 squared. Our goal is to write them using the same base number. Since I don't know what goes here, we can put an X. If they have the same base number, then they have to have the same exponent in order to be equal to each other. So 3x equals 2, divide by 3. The answer to this one is 2 over 3. Remember, the answer to a logarithm is that power. What are you raising it to make that happen? This will be my last example for you. 25 raised up to what power gives me 1 over 125? Alert, alert, alert. The argument was a number between 0 and 1. So my answer is going to be negative. Lucky for us, 125, oh, I was going to say could be written as 25 to a power. Wrong. We can write 25 as 5 squared, and then raised up to a power. And we can write 1 over 125 is the same as 5 cubed. So then I would do 5 squared to some power and switch this. So it says 5 to the negative 3rd. If the bases match, then these exponents have to match. So I'm going to put an x here. 2x is going to have to equal -3. Divide both sides by 2. X equals -3/2. These take some practice. Please, please practice in Delta Math. If it says it's wrong, make sure to come see me. I will help you to figure out what, if any, mistake you have made.